Welcome to the next lecture in the course Material Additive Manufacturing on non-destructive testing. The non-destructive testing methods are quite close to what we studied in reverse engineering. There are contact and non-contact methods. What is non-destructive testing? We will talk about this. The contact and non-contact methods, the technologies and the construction of the systems, and what are the application advantages and the demerits of these we will discuss. A quick light on ultrasonic testing, eddy current testing, magnetic testing, penetrant testing, acoustic testing, which are contact methods, and for the non-contact, radiography, thermographic testing, visual inspection, X-ray, CT scanning, it is computer tomographic scanning would be taken in this lecture. Now, non-destructive testing as a definition is a practice of looking the flaws or differences in a material or a component or an assembly without damaging the parts or system's capacity to function normally. So, it is a process of inspecting, testing, evaluating the components, assembly, materials, any discontinuities, so without destroying, without putting any harm to the component. So, when the inspection test is completed, the part can still be used. So, in contrast to non-destructive testing, there are tests which are destructive in nature. For example, there are the strength tests, the test for the tensile stress, for the compression tests, for the component that is produced. We try to produce a specimen of that, or sometimes we have to try to break the component, but in that case the component cannot be reused. So, there are two kinds of the inspections or testing that take place in the industry. Number one is sampling inspection, and the second one is sensors inspection. Sampling means we take out some samples, because if we have to break the system or break the sample or component, we cannot test all the say 10,000 components which are produced in a day. Out of the 10,000, samples have to be selected or sample has to be collected based upon a systematic way. That could be random sampling, stratified, clustered based, it depends upon the process how it goes. Sensors testing is when all, that is each and every component is testing. For example, each and every component could have been tested at least visually while looking at whether the color of the component is coming correct or not. So, the two kinds of testing, sampling and sensors, sampling versus sensors. So, non-destructive testing is always there when we have sensors inspection. So, these methods use the technologies which are used in manufacturing, fabrication, or the in-service inspections to ensure that the product integrity, its reliability, its control of in manufacturing process and the cost, everything is maintained at a uniform level. So, it is to make sure that the quality of the material and joining processes during the fabrication and during the erection phases, during the build-up phases of metal additive manufacturing or post metal additive manufacturing testing or the inspection of the dimensions, it is quite useful. So, to identify the damages or to identify the faults in the components or the prints that we have got, these tests are also they are useful. So, how are these useful? What kind of technologies are there? How are the technologies used in different fields in contact and non-contact areas? This we will see. So, it is inspecting, testing or evaluating the materials, components or assemblies for discontinuities or differences in characteristics without destroying the serviceability of the part or system. In other words, when the inspection or test is completed, the part can still be used. This is what is NDT. Now, modern non-destructive tests are being utilized in manufacturing, fabrication and in-service inspections and guarantee product integrity and dependability. This is to regulate the manufacturing process, to cut costs, to keep output levels uniform. Now, in service non-destructive testing, inspections are used to make sure that the products are being used to continue to have the integrity required to ensure their usefulness and safety of the general public. So, this graphics represent the non-destructive testing, the major of the tests in detail. So, we have the methods would be visual inspection, that is just by naked eye without using any passive or active method. We try to visualize whether the product or the component we have taken maintains or meets the conformance or not. Then film evaluation of radiographic images is there, ultrasonic inspection is there, dye penetrant inspection is there, magnetic particle inspection is there. Now, in dye penetrant inspection, you can see this penetrant, the spray or the liquid whatsoever we try to make to penetrate the component would definitely contact it. So, visual inspection could be we are only trying to see, we are not contacting physically to the component. So, we cannot divide them into two major segments, contact and non-contact method. In the contact methods, when the probe has to touch the component for ultrasonic, for providing the ultrasonic pulses, that is the ultrasonic testing as a contact method. Eddy current, the wires, the end connectors have to definitely connect. Similarly, in magnetic, they have to pass the magnetic field to the contact has to be there. In acoustic also, we need to have the vibrations in penetrant. In penetrant testing, the liquid or the spray or the aerosols that we will like to penetrate to the component would contact them. The non-contact method means we try to let the radio waves, or we try to see the thermal images or visual inspection, or we try to only have X-ray images, CT images of them. So, let us try to have a look on them one by one. Contact methods. Ultrasonic testing. This technique is used for detection of internal and surface defects in sound conducting materials. Short pulse of ultrasound is generated by means of an electric charge applied to the piezoelectric crystal. Pulse vibrates for a very short period at a frequency related to the thickness of the crystal. The frequency range varies from 1 to 6 megahertz. So, in ultrasonic testing, this is a setup that shows how ultrasonic system could help us to give the flaw, and it also tells where at what point the flaw is located. So, in ultrasonic testing, you can see initial pulse is this, initial pulse is this. So, it is showing it is all going uniform. Now, here it shows that here is a spike, here is a spike that shows that there is something not conducive here. That means there is a flaw. It notes this flaw, then it still start going it open. So, the wall echo could also happen in between. So, similarly, the flaw, sometimes the ultrasonic pulse is made to follow a pattern, then it reaches the flaw while coming at an angle. So, this flaw echo is because of this reason. At the end, it comes at this angle. So, in this ultrasonic testing, this is a straight beam, this is an angle beam. Straight beam and we have angle beam. So, in straight beam inspection, use longitudinal waves which interrogate the test piece as it is shown here, and if the sound hits the internal reflector, the sound from the reflector will be reflected to the transducer faster, and the sound coming back from the back wall of the part due to the shorter distance from the transducer, this results in the screen display. So, back wall echo is there, from it runs from the back wall and it gives this echo here, right. It goes and hits the back wall here, this is the back wall, and gives us a echo that is high. Now, back wall echo is when it hits the back wall and returns back. Now, we have the angle beam as well, in which the beam is mounted in such a way that it is angled or it is wedged, and it is designed to transmit the sound beam at a known angle. This angle could be any, maybe 45 degrees, 60 degrees, 70, 65 degrees or so. So with the angle being calculated to make sure that the line drawn from the thickness tries to have the information from the whole surface that is under the test. This whole surface is to be tested. So in the angle beam inspection, the transducer in the wedge combination that is moved back and forth, so that the test or the flaw or the fault that is there, that is recorded back there, and the flaw echo is generated here. You can see an echo is generated here. So there could be straight beam, there could be angle beam, then sometimes it is also immersed in water. So there are certain advantages of the ultrasonic testing, that the thickness and lengths up to 30 feet can even be tested. See how thick we can even go. So then the position, size and type of defect can also be determined, that is we get instant test results. It is a portable system. It is extremely sensitive, that is we get the test result immediately, and it is sensitive to the small faults even. It is capable of being fully automated. Access to only one side is necessary. We only need to have access on one side of the surface, and there are no consumables in this. So there are certain other advanced tests in the ultrasonic systems itself, like immersion testing. In the immersion test, the tank of water is there, and the water tank has a coupling medium that allows the sound beam to travel through them. So this ultrasonic machine is mounted on the movable platform on a bridge side of the tank, and it can travel down the length of the tank. So there are subtle ways also that we do, and through transmission also happens. So that is the transmitter and the receiver try to understand what is the test beam or the sound beam is trying to see. So we are talking about the ultrasonic testing from the viewpoint of the vibration and the sound beam as well. So there are certain disadvantages of the ultrasonic testing as well. For example, no permanent record is available unless one of the more sophisticated test results and data collection system is used. So it only gives the results, try to give you echo. If you record the echo, if you try to have the printout of it, or if we have the image record of that, that is fine. Otherwise, that is the data collection system has to be installed. The operator can decide whether the test piece is defective or not whilst the test is in progress. So indications require interpretation. It is interpretation from the, one is the operator, second is the machine itself. So there is an exception of digital wall thickness gauges which will take the interpretation by themselves. So considerable degree of skill is necessary to obtain the fullest information from the test. In this case as well, like in reverse engineering we studied, the tests are conducted in a battery of the series. Battery of the series means number of tests are conducted, then only the best results are taken. So very thin sections can be proved difficult to be tested using this. The applications for ultrasonic testing are when thickness measurement is there, when delamination and inclusions identification is required, when flaw detection in welds, casting and connections is required. Next kind of the contact method that we have is eddy current testing. Eddy currents can be produced in any electrically conducting material. The alternating magnetic field is normally generated by passing an alternating current through a coil. Any change in the material or geometry can be detected by excitation coil as a change in the coil impedance. So when a crack occurs or a flaw is there or a fault is there in the product, the eddy currents must travel further around the crack. So in the eddy current, you can see in this illustration that impedance change is there when the crack is there. So there is a change in impedance. See, there is an increased impedance when the crack is there. Here the crack is here. There is no crack. The pattern is completely circular. So in this case, the current is passed. The surface crack is there. The circle is distorted. So because the circle is distorted, currents go round and under the crack. So the increase of impedance is there. So that is what eddy currents suggest us, that the change in the impedance that is recorded as an electrical signal gives us the information on the current or on the defect that is there. So in eddy current testing, this uses the flux field. This is the flux field, and any change in the flux field in the terms of impedance change that is recorded. So the flow pattern of the secondary current here is actually the eddy current. Eddy current in itself means the secondary current So, and the encircling coils which are here are to be used to test tubular or bar shaped surfaces majorly. These coils are used. Now the product can travel in between, this product can go up and down, and encircling coil is there. So eddy currents could also be given here within the product itself. Here also the eddy currents could be given. So it depends upon the kind of the testing and kind of the shape of the product that we have. So advantages for it would be, it is faster process and little or no surface preparation is needed. It is easily automated, no contact is needed, no special operator skills are required. Extremely compact and portable units are available. So there are no consumables as well, other than sometimes the probes are there which are to be repaired time and again. We have flexibility in the selection of probes and test frequencies in the eddy current testing. This flexibility is to suit the different applications to different shapes of the components that we are trying to test. Disadvantages would be the probe size affects sensitivity. That is why the probes are repaired time and again, so that we try to fix it to the sample as close as possible. For simple geometries only this test could be taken. We cannot take test for the complex geometry. For example, the fins of an impeller, the components of a carburetor, it would be tough. Only the circular geometries, the straight geometries could only be tested. There is a shallow depth of penetration, that is we cannot go as deep as we could go in the ultrasonic testing. We could go up to 30 feet, it was given there. So generally tests are restricted to surface breaking conditions only. So and slightly subsurface flaws could also be taken. So if the flaw is here on a surface, that is fine. Slightly subsurface flaw, for example, if it is here very slightly, that could also be seen using the ultrasonic testing. So for example, if it is here and we have a coil here, so surface and subsurface both, like I will put and subsurface, that is very close to surface. Right. The applications would be cracks and porosity determination or identification, defect discontinuities, such as if seams are there, laps are there, small pits have been developed, cracks are generated, voids exist there, inclusions if need to be identified. Then material thickness measurement also to some extent can be taken through the eddy current applications. Now next comes the other contact method, that is the magnetic testing. The magnetic testing has a principle, that is to generate magnetic flux in the article to be examined, with the flux lines running along the surface at right angles to the suspected defect. Where the flux lines approach a discontinuity, they will stray out into the air at the mouth of the crack. So flux lines are generated, so the flux leakage is there. So this indicates that some particle is there or the flux lines are distorted here. The principle of magnetic particle inspection is given here. In magnetic particle inspection, the flux leakage only detects the anomalies in the normal flux patterns. So this is discontinuities. So in ferrous material, this is quite applicable. So this is used for piping, tubing inspection, then tank floor inspection, and other applications are also there. For example, in tubular applications, the inspection head contained is made up of drive and sensor coils and the position transducer. Those are connected by cables or some power source or so. So this head is placed around the pipe or the tube which is to be inspected, and drive coil is energized. The location of signal, that is sent by the gain position of transducer here. So we have definitely transducers are used for location of signal. Now tank floor inspection applies the same principle, but it uses a series of magnetic field generations, that is, bridges of magnetic fields are generated here. So in tank floor inspection as well, because the area is more, so more systems, bigger bridges are generated of the magnetic field, which helps us to understand the test the discontinuity growth if it is there, it tries to monitor that. So it is a faster process, it can be easily automated, little and no surface preparation is required, it is cheap and robust probes could be used here. The simplicity in the operation and the application is always there with magnetic testing techniques. It is a quantitative techniques, that is we get the results in the units of the magnetic field, that is Tesla, and it can be quantified because the data that we get is a continuous data here. The disadvantages that are attributed to this kind of the test is it is restricted to only ferromagnetic materials. It is also restricted to the surface or the subsurface or near surface flaws, just like eddy currents. So each component needed to be tested twice because we need to confirm the test and from the both the directions. The diagonal defects are difficult to detect here. The applications are the subsurface defects, checking pipes for crack and cast and wells, fully automated inspection of drive shafts could be taken, inspection of gears in general is carried out by the magnetic testing process. So drive shafts with material defect, then grayscale image of the magnetic testing indication is here. Then magnetic testing of a gear, how does it look like, how does the field flow, it is showing here. So to get this image of the magnetic testing of gear, certain parts of the magnetic testing setting system, okay, I could just name them. For example, prods are required, right? So prods use direct induction. So when current runs through the part or a circular magnetic field, it is generated around the legs of the prods here. So then the flux lines are generated and it tries to indicate wherever the distortion is here. Then we can also use coils even. So why coils? Because electric coils used to generate a longitudinal magnetic field only. And when this is energized, the current creates magnetic field, and the wires which make up the coils result in the flux lines which are oriented through the coil, and because of the longitudinal field, the indication in the parts placed in the coil are oriented in the traverse to the longitudinal field, so we get the direction, so we get the exact information regarding that. Also we have heads, movable heads as well. Heads means horizontal watt bath machines are there, which is a magnetic testing setup in which the heads are moved. It is just a movable head like a grinding machine setup or so. Then we have central conductors. Central conductors could be something equivalent to the coils which I just talked about, but these can be placed between the heads of the part and between the bar. So there are always these two can work in unison to get the output image and about the magnetic field information. Another test is penetrant test. The penetrant test means a medium has to penetrate into the material that is to be tested. It is frequently used for the detection of surface breaking flaws in non-ferromagnetic materials where the magnetic tests are not applicable because of their non-ferromagnetic nature. So penetrants are applied to the surface and enters the defect. Then the excess penetrants are removed from the surface. The developer powder applies to draw penetrant out of the crack. Then accentuated indication of crack as penetrant spreads around the opening. So we get the information about the crack, the amount of penetrant that is spread, and how it is developer powder tries to draw. So this amount of the penetrant and the shape of the penetrant also tells us that what is the crack behavior, what is the crack shape. So it is again simple to operate. It is the best method for surface breaking cracks in non-ferrous metals. It is suitable for automatic testing with reservation concerning viewing. It is a low cost, no sophisticated equipment are required, and again it is a quantitative method because we can get the information in millimeter, in grams, and we can quantify the information once again. The cons would be multiple stages in the complete process, so difficult to automate the system. It requires casting conditions like suitable of the light arrangement. This is restricted to surface breaking defects only. Surface cleanliness is required, sensitivity is lesser, it uses a considerable number of consumables because the developer, the penetrant, everything goes waste, and these are all consumables only. The applications definitely are there where the small portion is there and the full machine cannot reach there, but still we need to have the information of the crack. For example, this liquid penetrant testing on the concrete. So to test the shape of the crack and the type of the crack, the liquid is penetrated in this, then it is taken out using a developer. While taking out this system, we see how the pattern of that test, how the crack has been developed and what is the shape, what is the size of that, what volume of liquid has gone in it. So surface crack or porosity can be determined or can be identified using this. Crack detection in weld could be taken care using these kinds of tests. Just forging surface defects like laps, bursts can be easily identified by performing a liquid penetrant test. So next is another contact method, that is acoustic testing. The term acoustic emission refers to the generation of transient waves during the rapid release of energy from a localized surface within a material. In an acoustic emission test, an inspector records elastic ultrasonic waves traveling through the surface of solid material using one or more sensors. So we have elastic ultrasonic waves here which travel through surface of the solid material. Sensors are there. What these sensors record, we will just see. As an acoustic wave travels on or through the surface of an object, any defect it encounters can change that wave. So this change in wave has to be now captured. So this is change in waves happens in the terms of the speed of the wave or in the terms of the amplitude of it. So this has to be recorded. So in the acoustic testing, it is performed by applying localized external force such as an abrupt mechanical load, right? So then a rapid temperature or pressure change happens. The resulting stress waves in turn generate a short-lived or high-frequency elastic waves, which are in the form of a small material displacement. So this small material displacement is recorded here using sensors. So it is detected by sensors. When multiple sensors are used, the resulting data can be evaluated to locate discontinuities in the part. So this is how it works. This is the principle of acoustic emission testing. It has an advantage that it gives you direct measure of failure mechanisms. It is again highly sensitive, with the small cracks or small defects could be identified using this. It provides data immediately or instant readings could be taken. It is a non-destructive test to the material being tested. It allows for a structure to be globally monitored. It can be used in hazardous environments as well. It can be done remotely and can detect defects in materials that might be hard to test using other non-destructive testing methods because it can be used in the hazardous environments as well. So the disadvantages is that its useful is generally limited to locating a defect, not describing the defect in detail. It only gives you the signal, yes, the defect is there is a change in wave, but what is the size, shape, the measurement, quantitative techniques cannot be applied on it. So this means that commercial acoustic testing systems can only provide qualitative estimates only. That is, test is there or not, yes, no, right? It cannot give you test of this quantity, this measure is there. It cannot detect the defects that do not change over time. It can be slow to implement. It can be hard to use because acoustic signals are very weak. So there is a lot of noise and signal discrimination. What is the signal exactly to be measured? What is the noise? This is the unwanted readings, unwanted output. So differentiating between them sometimes becomes difficult. So it is not very simple test, but still it has an applications to test for the cracking, corrosions, delamination and breakages. Airplane longevity estimation is taken care by applying the acoustic testing methods. Then bridge applications are there, concrete corrosion monitoring is there, mine wall stability, pressure vessels, structural integrity inspections, wind turbine inspections are taken care by the acoustic testing methods. So with this, the part 1 of the lecture on non-destructive testing is completed, where we have discussed the contact methods only to have the non-destructive tests on the materials and the components. We will meet in the next part where we will discuss on the non-contact methods. Thank you.